Hey everybody. All right, I'm going to get straight into this today because I am in a little bit of a time crunch. Sorry, the video is a little bit worse quality. I hope the audio is okay. I'm having to use a different camera today. But anyways, we are in section 2. Get this going here. Let's see if this will focus. Looks pretty good. Okay, we're in section 2, and we kind of talked a little bit already about representing the transformations graphically and numerically and how those affect the coordinates of the points. The other thing in section 2 that we need to learn how to do is the graph of these piecewise functions. We've kind of seen a piecewise function before, just like once, but we didn't graph it. So we're actually coming up with a graph of this function. What these functions really mean is it's kind of one function that's made up of 2 different pieces, and each piece is used for different x values or for a different domain. So if x is between -1 and 4, then this function is defined by the first piece. And if x is bigger than 4, then we use the second piece. And we just need to graph that on here. So you're going to have just like 2 different pieces graphed on the same graph, depending on what the x coordinates are. So I have kind of my own little method that I kind of teach on how to do this, which makes it pretty simple. And that is, I always just want you to plug in these border numbers straight into that piece. And I don't want you to worry yet about whether this says equal to or not. See how this one's just less than, but this one's less than or equal to. So like the -1 is not included, but the 4 is. I don't want you to worry about that just yet. We'll worry about that in a minute when we do the graph, but we're just going to plug in -1 and 4. We're going to plug both of those in to this first piece here. So if x is -1, -1 minus 2 is -3. Square that, you get 9. 9 minus 3 is 6. I have a y value of 6. Now I'm going to do the 4. 4 minus 2 is 2. 2 squared is 4. 4 minus 3 is 1. And I'm going to have a point at 4, 1. All right, so we're just going to graph this first piece, and these are like the end points of that piece. So I'm going to go to -1, 6. -1, 6. And I'm going to have a point there, but now is when I take into account that that -1 is not actually included in this domain. Meaning we don't actually want to have a point whose x coordinate is -1. And the way I'm going to represent that on the graph is I'm just going to put an open circle there at -1, 6. So this gets an open circle on the graph. Whereas the 4, 1, I'm going to put a closed circle because the 4 actually is included in that domain. Now guys, the further along we go this year, the easier it's going to become for you to graph the rest of this thing, because we're going to have like a whole chapter on graphing quadratic equations. For now, you can just keep plugging in numbers, and you know that you need to plug in numbers between -1 and 4, right? That's where this function exists. So you could start with like 0. 0 minus 2 is -2. Square that, you get 4. 4 minus 3 is 1. So we have a point at 0, 1. If you plug in 1, let's see, you would get -1 squared is 1. 1 minus 3 is -2. 1, -2. If you plug in 2, that would give you 0 minus 3, which is -3. If you plug in 3, you'll get -2. And now you can graph your little parabola there. So you can just get those points in the middle by just plugging them in. All right, sometimes it'll be even easier than that, though. Sometimes you won't even have to do that. All right, let's do this second piece. I'm going to do that with my blue pen here. And there's only one end point on this one, which is just 4. Again, don't worry about whether it says equal to or not. Just plug it right in there. So 2/3 times 4, oh geez, that's 8/3. And then 8/3 plus 2. Well, 2 is 6/3. So that's 14/3. I don't normally use mixed numbers, but I think this is a good time to do it. So that would be 4 2/3. So I'm going to have a point there, but it's going to be an open circle because there is no equal to here. The 4 isn't actually included in this domain. So I'm going to go to 4 and then 4 2/3 and do an empty circle there. Now this piece is a line. I mean, you can keep plugging in x values here. This piece is a line with a slope of 2. So I could start at this point and go like up 2, right 1, point, up 2, right 1, point, up 2, right 1, point. You'll notice that my points are like 2/3 of the way up because this was 4 2/3. Draw your line, you got your graph, that's all there is to it. Okay, we'll go on and look at example B here, which is h of x. And so I'm gonna use my green here. For this first piece, we'll do this first piece in green. Again, notice that there's only one kind of border number here, and it's -1. So I'll do my x and y up here like this. All right, so if I plug -1 into this first piece, -1 plus 2 is 1, absolute value is 1, 1 plus 1 is 2. So I'm gonna have a point at -1, 2, and I have to think whether it's gonna be open or closed. -1 doesn't actually, is not actually included in this domain, so -1, 2 is an open circle. Now I have to graph the rest of this thing, and I'm just gonna keep plugging in numbers that are less than -1. So I could plug in -2. That would be 0. 0 plus 1 is 1. So -2, 1. If I do -3, that would give me 1 plus 1, which is 2. So -3, 2. -4 would be 2 plus 1, which is 3. Okay, so it looks like we're getting to that part of the V-shape absolute value graph where it's just going to go on forever, like linearly in that direction, but then you get your little V shape there. Okay, so you don't have to plug and chug too much. For this middle part, it says when x is equal to -1, y is equal to 3. When x is equal to -1, y is equal to 3. So when x is -1, y is 3. So we're just going to have a point there at -1, 3, and I did that in red. That's just a single point. That's all that is. The third piece here, let's see, this is going to be linear. I'm going to plug in -1 here. So -0.5 times -1 is +0.5. Add 5 and we get 5.5. Now there's no or equal to here. -1's not actually included in this domain. So at -1, 5.5, I'm going to have an open circle. From there, I just know that this line's going to have a slope of -0.5. So I can go down 1, right 2, point. Down 1, right 2, down 1, right 2, all the way across here as far as I can go. And then I can draw my line. And that's my piecewise graph. That's how it works. We got 2 more to go. We're moving right along here, aren't we? Okay, let's go to the back page here. We've got some room underneath to use now. All right, so for this first part, oh, that's got a square root in it. I've got 2 border numbers. I'll go ahead and just do this again. So my 2 border numbers are -4 and 0. So I'm going to start by putting -4 in here. Now this is -x, and x is -4, so that's like -4, which would just be 4. Square root of 4 is 2. 2 plus 3 is 5. If I put 0 in there, 0 plus 3 is 3. I need to decide which one's going to be open and which one's going to be closed. That -4 has an or equal to there. So this first point's going to be a closed circle. 0 does not have the equals there, so that second point's going to be an open circle. So -4, 5, closed circle. 0, 3, open circle. See, these are like the end points of this piece. The rest of this graph is going to exist for x values in between -4 and 0. So the rest of the graph is just going to exist in between these 2 points. So if you have to plug some points in, it's no big deal. But, well, I don't know. Let's just do -1. So that would be 1 plus 3, which is 4. So -1, 4. And I kind of know that square root functions kind of have just that curved shape to them. This one happens to be flipped, like over the y-axis and moved up a little bit. So the graph's just going to kind of look like that. And I'm fine with you just drawing that curve. That's completely fine. All right, for this middle piece, Again, we've got just a single point. When x is equal to 0, y is equal to 2. So we're going to have a point at 0, 2. Just a single point there. Done. All right, let's go to this third piece, another square root function. There's only one endpoint to this domain, and it's 0. So let's plug 0 in here. You get 0 plus 3, which is 3. Notice that there's no or equal to. 0 is not actually included in this domain. So I'm going to do an open circle here at 0, 3. Oh, look at that. There's already an open circle at 0, 3. Cool. Now let's just kind of plug in some other numbers. If you plug in 1, you get 1 plus 3, which is 4. I'm not going to plug in 2. I'll plug in 4, though. I can do 4. Square root of 4 is 2. 2 plus 3 is 5, so I can go to 4, 5. How about 9? 9 would give me 3 plus 3, which is 6. Again, we kind of know that those square root functions have just that curve to them. That's your graph. That's it. All right, for example, D. This first piece, oh, this looks a little bit more complicated. That's okay, we'll handle it. Look at our domain. There's only one kind of boundary number here, which is -2. So let's plug -2 in here. So the minus on the x would make it a +2. So 2 minus 2 is 0. Square root that, you get 0 plus 2 is 2. -2 is not included in this domain. So I'll do an open circle at -2, 2. And now I'm going to graph the rest of this piece for x values less than -2. So that would be this part of the graph down here. We can just kind of plug in numbers. Let's see. How about if I try -3? So if I put -3 in here, I would get 3 minus 2, which is 1. That would end up being 1 plus 2, which is 3. So I'd have a point at -3, 3. Let's see. What if we went to 4? That's not going to work. How about 5? No, 5 won't. How about 6? Let's go to -6. So if x is -6, this becomes 6 minus 2, which is 4. Square root that, we get 2 plus 2. Okay, so -6, 4 is a point. Right now, I kind of know that I'm going to get this square root curve, and so I'm just going to go ahead and graph it like that. All right, let's do this middle piece. -2x minus 2 is linear. So I know that this is going to be a line, but I've got two numbers to plug in here, -2 and 1. If I put -2 in here, -2 times -2 is 4. 4 minus 2 is 2. If I plug in 1, I would get -2 minus 2, which is -4. The first point's going to be open. The second point's going to be open because there's no equals here. -2 and 1 are not included in these domains. So -2, 2, oh, there's already an open circle there. 1, -4, I'll do another open circle. Now this is a line that has a slope of -2. So I can just start at a point and go down 2, right 1, down 2, right 1, down 2, right 1. And look, I landed right back on that open circle again. That didn't really look like a line, but it's supposed to. Last piece, this bottom piece. We've only got one endpoint to plug in, so let's plug in the 1. If I put that in here, I would get 0 minus 4, which is -4. That's going to be an open circle. There's already an open circle there. And then let's just start plugging in some numbers. I'm going to plug in x values that are bigger than 1. So how about 2? 2 minus 1 is 1. Square root it, you get 1. -1 minus 4 is -5. So I'd have a point at 2. -5. The next thing I plug in should be 5, I think. If I plug in 5, I should get -6. And then the next one that would work would be 10. And if I plug in 10, then I'd get -7. And then that square root function is going to have that curve to it. So -2 and +1 are not even in the domain of this function. All right, so that's it. That ends section 2 for us, which is graphing piecewise functions. I am going to cut it off there because, like I said, I'm a little short on time here. I got a class starting in a few minutes, but looks like we made it. So hopefully you're taking care of yourself, stay healthy, and I will see you back here as soon as possible. Goodbye.